When people first hear about transformers and self-attention, they often see a wall of matrices, dot products, and math equations. But underneath all that math is actually a very simple and intuitive idea. A single word inside a sentence does not have really meaning by itself. Its meaning emerges from its relationships with the other words around it. This simple idea is at the heart of transformer architecture and self-attention. So I thought in this video we could forego the math and we can try to build this intuition step by step, starting with simple word embeddings, following them through so-called queries, keys, and values, and seeing how meaning emerges through self-attention inside LLMs. We have to start with one sentence, and I often see examples using this sort of simple or simplistic sentence. But for our purposes, I feel that I could start with a more realistic sentence. Let's take this one. The lawyer questioned the witness because it contradicted the evidence. Okay. This sentence is deliberately ambiguous. We don't know exactly what is going on, though we can get a good idea. Okay. So if we focus on this sentence, the lawyer questioned the witness because it contradicted the evidence. Now, what does it refer to here? Okay. So for the rest of the video, we will try to understand how transformer and self-attention works to understand the concept of it. Now, it could possibly refer to the lawyer. Maybe it refers to the witness, or in this sentence, maybe it refers to the evidence. At this point, we don't know. Okay. And we'll see how step by step this understanding of the sentence will occur. So initially, all I have done here is taken these 10 words. This sentence has 10 words. I've kind of listed them vertically here. The lawyer questioned the witness because it contradicted the evidence. And all transformers or transformer architecture in this whole self-attention mechanism, we start with the raw word embeddings. Okay. So each word becomes a series of numbers. That's all. So if for my example, I'm using 3 numbers. For example, the word witness is represented in our example, in the toy example, by 0.77, 0.59, and 0.33. But of course, 3 numbers won't do it. In a realistic architecture, there are hundreds and even several thousand plus columns of vector of numbers. But just to illustrate, okay? And the important point to remember here is that these things, which are called the word embeddings, right? This vector of numbers is where the static meaning of each word is stored across those numbers. All right. And if we don't want to use numbers and if we want to focus on understanding, so we can think of static meanings of the word witness is stored in numbers that represent some concept of testimony. A witness usually appears in a courtroom. A witness is someone who has observed. So there is an observer aspect to it. And a witness is also a person. Okay. And also look at the word it. It is a pronoun and it's a placeholder. At this point, we don't know much about it. The generic meaning of it is not very helpful in understanding this sentence because at this point, embeddings only convey the static meaning of words. As the next step, after we have attained the word embeddings, is to take each word embedding and pass it through 3 different lenses. Okay. We will get to what these lenses mean in a second, but for now, let's just visualize this. You take every word, take the embedding of that word, and we're going to pass it through a lens so that it comes out slightly transformed. Okay, so we're going to take 3 different colored lenses here, and I'm going to pass it through the orange lens. So certain aspects of this word will be highlighted, and then the blue lens and a green lens. Okay, so now the natural question is, what do these lenses represent? For that, we can think of the orange as a query matrix or a weighted learned query matrix, which says what features should this token use when searching for information. Now imagine each word in the sentence trying to understand itself or understand its role in the sentence. Okay. So what should it search for is the orange part. So in this case, each word is also searching and also will give information to others when asked. Okay, so they act as two-way messengers. So the blue matrix says that if any other words comes to me and asks, then what do I contain? Okay, and that's the key. So the blue is the key matrix, and the resulting vector will be the key vector, the blue key vector. And finally, the green one is the if there is a good match, the green one is the actual value vector, which is what this token will give all the others. Okay, this is still abstract. It will become clearer the more we look at. So let's go on so that this becomes clearer. Now, the entire pipeline looks like this. We take the raw embedding of each word, we pass it through a matrix so that new identity of each word emerges, new identities. Okay, we can give these things names. So the first one is what we could call the attention request vector. What information should I look for? Okay, the word it is looking for some information. The key is the attention match vector. If it comes to me, the word lawyer thinks, hey, what is a good match between me and the word it? And similarly for witness and so on. And if there is a very good match, what is the actual message that I should give? Again, this will become clearer as we proceed. So for the next step, let's go back to our sentence. The lawyer questioned the witness because it contradicted the evidence. Right? We now have queue of it and we have several keys available. So in our example, what could this word imply? So the word it itself goes and queries all the other words and says, hey, who among you could be contradicting me? So it might go, for example, the Q of it could check with the K of the lawyer, the key of the lawyer, to say, is it possible that the word lawyer contradicts me and therefore the word it is referred, the lawyer is what is referred to, or could it be the word witness or evidence? So it turns out that for this answer, right, many different words hold the key to this query. Next, we have to look for a Q and a K match. Okay, again, going back to our main sentence, we are focusing on the word it. And we see that its neighboring word contradicted may hold some clue. So we could perhaps, conceptually speaking, take these two. And then the query vector of it will ask, hey, what is something or someone that contradicts me? Okay. And in our candidates, it could be the lawyer, in which case we will have to look at the K of the lawyer, the keys that the word lawyer holds. Okay. Or it could be the keys or the K vector of the word witness, or it could be the key vector of the word evidence. Okay. And now it's time to do the matching. So we'll bring them together, so to speak, and look for an attention similarity. This is the phrase that we are giving to doing a dot product. The Q gets multiplied, Q of the one word, it gets multiplied with the K of all the other words in the self-attention mechanism in the sentence. And then we give a score. Could the lawyer be contradicting it? No, the lawyer is doing the questioning. So perhaps the lawyer is not contradicting, in which case it will get a small score. Could it be the witness? And let's say in this case, it seems to be a good fit. So it could get a higher score. Or does the evidence contradict it? In which case you can give it some other score. So in this manner, we are getting attention similarity scores. So for those who want to dig a little deeper and understand attention similarity, what we are doing is we are taking the desire of the word it to understand itself, and then we're going to match it with different keys that all these words bring. Okay, that's what the Q dot K, similarity attention. That's what is going on here. So the K of a lawyer is a person, an agent, whereas the K of a witness says, hey, I'm a witness, therefore I am a person, but I'm also a source of information. Whereas the keys that the word evidence brings is that I am a thing or a concept, and evidence is inanimate, it's abstract, it's an object, and so on. And then in our example, we look for matches, and at this point, it looks like the word witness may have a strong match. That's what we have done. so far. A different analogy that people use is one of attention score as an unlocking mechanism. In this case, we look at the cue of one word, in this case it, and see which K had a very high match, right? A strong match. Let's say it's K of witness. And therefore, we sort of say that the word key of the word witness has unlocked Q to use it, and therefore the word it is now free to use V. Remember, there are three lenses, right? Three vectors, but we have only focused on Q and K. But if there is a high match, then it is free to use the V, the true value that the word witness brings. Okay, that's what this analogy is doing. And so how do we know which one has a high match and a low match? We simply do the dot product, right? We take our three Qs and then in our case, three candidates, and then we just do the dot product, compare Q of it with the K of lawyer, K of witness, and K of evidence. They will give us three numbers. Let's say in this example, it's 0.2, 2.3, and 0.7. Now notice that these numbers don't mean anything by themselves. They're just relative sizes. So we could do something called a softmax, basically bring it down, scale it or normalize it. And then we can then look for which attention similarity is high and which one is low. So now we have these three similarity or relevance scores. We have done the Q dot K dot product. And therefore, intuitively, what it means is the relevance of each of these candidate words, lawyer, witness, and evidence, to our original word, it. Okay, so we are asking how relevant is the word witness to help us understand the word it. And in this case, it's highly relevant going by these scores because 0.45 is very high. Whereas the word lawyer, less so, the lawyer is not contradicting it, and evidence also not. So in the self-attention mechanism, the word it is asking, should I pay attention to the word witness? And the answer is yes, you should, because there is a high match, high similarity, high relevance. All right. So again, to recap, after doing this whole attention similarity or calculating the scores, it turns out that witness, for the word it, witness takes on high relevance, lawyer less so, and evidence even less because evidence is not contradicting itself. Okay, we still have one more step left. Now finally we have the relevance scores. Remember the V vector, the green value vectors that we didn't use at all. So we will bring those now and we have to give them some weightages, okay? For it to understand itself, it takes the weight of the word lawyer, the relevant similarity score of the word lawyer, plus the similarity of the witness, give it a 0.45 weightage, and take the word evidence, give it a 0.15. And when you do all of this, the weighted sum of all these values and vectors leads to meaning emerging, okay? Or in English, thanks to the self-attention mechanism, when we take a sentence and we were trying to understand what this word it meant in it contradicted the evidence, we had initially started with a very generic pronoun. We didn't even know what it could mean, but having gone through this whole exercise, after self-attention, it must be some testimony-like thing by a witness which contradicts the evidence. That whole thing has emerged thanks to the self-attention mechanism. So thank you for your time. I hope that was somewhat useful.